Okay guys, here's our next segment on our naming unit. We have gone through everything we need to for ionic compounds and molecules, and now our last step here is to talk about acids and then organics in our actual final segment. So acid naming, one thing we need to realize is that an acid really is an ionic compound. It's just an ionic compound that starts with hydrogen. We'll get into acids and how they work and their properties and the chemistry they do later on in the year, but for now it's just important for us to be able to identify them and name them properly. So when we're looking at our compounds, if it starts with hydrogen, we know that that's going to be an acid. So we have to name those differently. It's a different set of rules. Okay? And what it comes down to is what type of anion or negative ion that we have in our compound, and that dictates how we're going to name it. Okay? So we either going to end with a polyatomic ion or a monoatomic ion, and each one has its own little naming system to it. So let's talk first about monoatomic ions. If you end with a monoatomic, meaning a simple anion, something like just chlorine or just fluorine or just bromine, then what we do is we start the naming system with the word hydro. We put in the root of whatever anion it is, and we put ic afterward for acid. So for example, if we had hydrochloric acid, okay, so we have HCl. We look here, and this is a simple anion. Another way of looking at it is this would normally end in IDE. So if it normally would end in IDE, the way we name this is because we have an IDE ending and a simple anion, we put the prefix hydro up front. This is chlorine, so we would call that chlor, and then we end it with ic acid, and the word acid does need to be there. Okay. If this was a different anion, let's say it was fluorine, we would just have hydrofluoric acid and so forth. Okay. And then of course, if you have hydrofluoric acid, anytime you see the prefix hydro, that tells you that you have the simple anion. So if you see hydrofluoric acid, you know that it always starts with H. Fluoric is your root, and because there's hydro up front, you know it's just the fluorine and nothing else with it. So that's monoatomic. If you have a polyatomic, so if your anion ends normally in 8 or ite, we don't use a prefix hydro with it. Instead, we drop that prefix off and we use two different endings to designate between 8 and ite. Okay? So if we had HClO3, this is a polyatomic. This is chlorate. And the 8 is our key here. So we have chlorate. So because it's a polyatomic, we don't use hydro. So we just use the root, chlor, and anytime you have an 8 ending, you keep ic with it. So chloric acid. So 8s we end with ic. Ites, same scenario, but we end in us instead. So if we had HClO2, which would be chlorite, still a polyatomic ion, so we don't use hydro. But now, instead of calling this chloric acid, we can't call it the same thing, it's a different compound. It ends in ite, so we put us with it instead. So this would be chlorous acid. And then of course, if we go down another one, and now we have hypochlorite, so we have the prefix hypo on here. We can now use this prefix in front of here to indicate it's the hypochlorite and not just the ite. So without any options here, HClO would be hypochlorous acid. Okay, so it's using a lot of the same stuff we've already done, but just kind of changing it so it matches an acid naming system instead. Obviously, if we can go down to hypo for our S's, you could also, if you have a perchlorate, you could also have perchloric acid. So let me show you that one quick. So if we had HCl4, that would be a perchlorate, still a polyatomic ion. So we have to say perchloric acid for that. Okay, so that's every option for those. And again, if you see perchloric acid, the per tells you that you have perchlorate. So this tells you what your ion's going to be, and it always starts with hydrogen. So you know it's HClO4. Okay, one thing we have to make sure that we do when we're naming acids is we also need to be able to balance our charges within acids, because acids are actually ionic compounds that just start with hydrogen instead of any other metal. So hydrogen in this case has a +1 charge. So any of our anions we put with the hydrogen, those two things have to balance out charge. So if you had the chloride, to make hydrochloric acid, you need to have HCl, where you have a 1-to-1 ratio. However, if you had hydrogen with, let's say, sulfate, sulfate has a -2 charge. So with a -2 charge, you need to have 2 hydrogens to balance out the sulfate. So for sulfuric acid, we would need to have H2SO4. If you had something like hydrogen with phosphide, phosphide has a 3- charge, same idea. 1 hydrogen to 1 phosphorus would not be neutral, and you need a neutral ionic compound here, so you need to have 3 hydrogens for every 1 phosphide for hydrophosphoric acid, sulfuric acid, or hydrochloric acid. So when it comes to acids, you need to put enough hydrogens in to neutralize the compound and make a neutral compound. Okay. Now the bases, naming bases are exactly the same as you would name any other ionic compound. So we don't really have a system for those. That's just something we're going to mention in this little lecture here. Okay, guys, that's everything for acids.